Hello guys, welcome to the new lecture in the vector series. Today we'll be talking about vector part 3. So from earlier lectures we already know that vector is an STL container and we can loosely call it a dynamic array. For more information you can refer to my earlier videos. In this today's lecture we will be talking about most frequent questions that interviewers ask you when talking about vectors. So the first question could be, how would you initialize vectors with size of 8 and all elements as value 10? So basically here the interviewer wants to know the syntax of vector initialization. So as you can see, the simple answer would be std vector, the data type, the vector name, and first the size and then the value of the element. After this, all the elements in vector int will be initialized with the value 10 and there will be total of 8 vector elements. The most important thing here to understand is we are talking about size, the number of elements in vector. We are not talking about capacity. Capacity is how many elements a vector can actually hold. So this depends on the system limitations and it varies as your program progresses. I have already discussed about capacity in one of the earlier videos. You can refer to that. Any questions? Just write a comment. Second question could be, what happens if you try to push 6 elements in this vector? So basically, if you have 5 elements already in a vector and you try to push 7th element, what will happen? So vector will resize using move. This is really important. When we talk about C++11, we talk about vector resizing using std move. So what actually happens is, if there are already 5 elements in vector, you try to push a 6th element, there is no space. So in that case, internally a new memory space is being allocated and the vector contents will be moved to that place. So here I specifically use move. I am not mentioning copy because copy is a costly operation and C++11 has optimized it to use a move instead of a copy. So move is just removing a pointer from the source location and relating it to the target. So that's why your move is really fast and performance efficient in comparing to your copy operation. The next question is, what is iterator invalidation? So this is a generic question. I won't relate it to vector specifically, but if you are using any container that supports iterators, the question may come. So as the answer is, iterator becomes invalidate when the container it points to change its shape internally. That is, it move element from one location to another and the initial iterator still points to old invalid location. It's very cryptic, so let me decrypt it for you. When you have one iterator that is pointing to a specific vector element and you delete something from the vector or you insert something in the vector, it means vector might have changed its location, size, or anything that you don't know. So basically we are talking about shape of the vector. So in that case, the iterator that was pointing to the vector earlier is now invalidated and you need to get a new iterator to make it work. I'll show it with the example. Just hold for a second. Now this is the example. So here you can see I have taken iterator t, which is pointing to the beginning location of my vector. Now I have inserted a new value in it, 200. This will go to the beginning of this vector. Now again I have received the return value of insert in a new iterator. So basically this iterator it is now a valid iterator. It is not invalidated as I have taken the newest value from insert. Now I am inserting at this location. Now after this insertion, this iterator is gone invalidated because I have not received this value here, so we cannot use it. The next question is how to insert values in vector. So there are so many ways in to insert a value in a vector. Could be insert function, could be pushback, could be emplace, could be emplace back, so there are so many ways. Here we are talking about few ways, and in the next lectures I will be covering more, because emplace is not a thing which I can cover in lecture with other things. It should have a complete video to do justice with it. Then another question could be, which is more efficient, insert or pushback? Why? So pushback is most of the time most efficient, but sometimes it's equal if I'm inserting at the end of the vector, because when I insert something in the middle of the vector, it means the rest of the elements has to be shifted backwards to make space for the new element. As we know, vector is having contiguous memory for it, so it's a very costly operation. So most of the time you try to do a pushback, which is really efficient, as we are pushing an element in the back of the vector, so basically no adjustment. Now we'll quickly go through one exercise which I am having here. So you can see I am using a vector int, and I've initialized with 8 elements, all with a value of 10. So when you print vect.int.size, it will give you 8. Then you can print all the vector contents, and we already know the syntax from the last exercises, and it will display all 10. Then now we talk about when you use a iterator. Auto, you already know it is from C++11. You do not to specify the data type explicitly for it, it will deduct from the assignment statement. Now when you do a insert, the return newly inserted position, that is the beginning. Okay, because we are inserting in the beginning itself, you can understand this it is the beginning, and we are inserting 200 at it, so now 200 will be the first element. Now we are inserting again 2 elements, so this is again an insert syntax that you can learn, but trust me, if you even say you don't know this syntax, nobody is gonna fire you from the job. So basically you are inserting 2 elements at it position, and the value of those 2 elements will be 300, and you are printing it again. So basically what you are gonna have in your new vector, 2 times 300, then 200 as we have already inserted here, and then 10 10 10 10 8 times that we have already inserted. How to compile this program? You know this already. G++ minus standard C++11 and your file name, whatever you are naming it, and then to run it a.out. Okay, thank you for your time, and wait for my new lecture. Thank you. Bye bye.